Now we're coming back to function transformations, but we're going to apply them to sine, cosine, and that type of stuff. What does the a mean? Remember, the a is going to y numbers. If we're thinking about y equals sine x as our original graph, and so if we have for example, 2 there, it's going to be multiplying those y values by 2. So a is going to do the vertical stretch. Now, in terms of looking at a sine, cosine type graph, what is the a doing? What it's going to do is affect the amplitude. And we've already looked at the amplitude again. Now, can the amplitude ever be negative? No, because the amplitude, recall, is our 1/2 the max minus the min. It's the amplitude. So the max is always going to be bigger than the min. So the way we're going to do that is we tack on the absolute value to the a. What does the b do? The b is going to be the number of complete cycles / periods in one normal period. So if it said, for example, sine of 2x, that would be 2 complete periods in 0 to 2 pi. And that's going to allow us to solve and find out what the either the period is or b is, depending on the problem. And then d is our vertical shift. So if it said +5, that would mean move the whole thing up 5 units. If it said -4, it'd mean the whole thing down 4. Notice that we don't have the x minus c part yet. We'll get to that one later. Now our book will do things a little bit differently. They're going to move the d to the other side. Just do it like this. This is more consistent with what we've done. The book is inconsistent, wrong with that idea, but if they were more consistent about it, I would use it. All right, find the amplitude period of each equation. So actually, we could probably come back up here and write, if this is b complete periods, we'll have b periods equals one normal period, which is 2 pi. And one reason why I say use one normal period is because for tangent, the same idea applies, except the period of tangent, as you know, is pi instead of 2 pi. So when we come down here, we can say the amplitude. Well, this one's not too bad because there is no vertical shift to it. We can say, I'll show it though, 2 minus -2 divided by 2. And yes, it's just 2. And we can see that because it's going to be the distance from your midline up or from your midline to the lowest part. It's going to be that same distance, which is 2. Now we have b periods. And what is the period? The period is how long does it take to repeat? Well, this is starting here, and it ends at 18 pi, and it's going to start again. So the period in this case would be 24 pi. So the p will be 24 pi. Now to find the equation, we'll have b times 24 pi equals 2 pi. So b is 2 pi over 24 pi, which is 1/12. I like to do this as b periods because you can see that in the graph, as opposed to memorizing a formula that doesn't necessarily have any meaning to you. Now we have to decide what type of graph is this. This can be a sine or a cosine. And since we're not dealing with horizontal shifts, it should be apparent depending on where it starts. Where does sine start? Sine starts in the middle. Where does cosine start? It either starts at the max or the min. If it starts at the min, that would mean it would have a negative a value. In this case, it starts as a max, so we're going to deal with cosine. And there is no vertical shift. So we can just plug in the information. We have y equals, our coefficient is 2, cosine of 1 over 12x. Let's take a look at the next one. What is a value? A is going to be our max minus min divided by 2, or we can say the distance from the midline to the max, or distance from the midline to the min. And when you see that the upper number and the lower number are the same except for opposite in sign, that's just telling us it's 3. What's our period? Period's how long it takes to repeat. We're going to take 8. So that means b times 8 is 2 pi, or in other words, 2 pi over 8, which is pi over 4. Now in this case, what trig function are we dealing with? It's starting in the middle, and so we're dealing with sine. Oh, do we have any vertical shift? No. No vertical shift. So in dealing with sine, but sine normally starts going up, and in this case we're going down. So what does that tell you? That means a is different. That means a is a negative 3. And over here, actually I should come over here and change and put the absolute value of a, because it actually said to find the amplitude as opposed to finding a. So a is negative 3. And then we can write y equals negative 3 sine of pi over 4x. Now this time, instead of being given a graph, we're going to be given the equation, and we're going to find the same information. What is our amplitude? Well, our amplitude, this time I'll just write amp, will equal the absolute value of negative 3.5, which is just 3.5. What is the period? Well, we know we have b periods. What's b? B is the coefficient of our variable. In this case, it's t. So what is that coefficient? If we had to write this as some number times t, it would be 1/4. So 1/4 of period equals 2 pi, so the period in this case will be 8 pi. And let's take a look at one more of these. We'll say the amplitude, here we can see that as 5, and we have pi over 3 times the period equals 2 pi multiplied by 3 over pi, and we get the period in this case is 6. And that's all that one is. Let's take a look and try to apply this to this particular problem. And this time, this is a little bit harder than those ones I just did because this has a vertical shift. So let's take a look at what we know here. We know the amplitude is 3. We know we have 2 periods in 2 pi, or in other words, 1 period in pi. And we have a vertical shift of 1. So we can start by going this vertical shift of 1. From there, we know we're going to go up 3, 1, 2, 3, and down 3, 1, 2, 3. So we're going between negative 2 and 4. And we have a period of pi, so we have to complete the full cycle in pi. Now, what is sine? Where does sine start? Sine starts in the middle, at the midline. So in this case, it's not going to be on the x-axis. It's going to be at this 0, 1, because everything was shifted up 1 unit. And then what it's going to do is since this is a positive, it goes up. Now I'm kind of cheating here, and I'll deal with this in just a second. Where does it end? That point right there, what is that value? Well, that's our period. This is pi. What's this piece here? That's going to be pi over 2. And what I've said many times so far is I want you to make sure that you are labeling all your key values. So this one here would be pi over 4, and this would be 3 pi over 4. Now, how did I get that? This one's pretty easy, straightforward. because you could say if this is pi, half of pi would be 1/2 of pi, and you could say half of that because we're going from mid to high to mid to low to mid. Those are all equal, and the the distance it takes to go to the high is going to be the same as it takes from going from the high to the mid. So we can just say half of pi over 2. Another way to do it would be to say 1/4 of the period equals pi over 4. And I've said to label 5 numbers. Why 5? We have our starting point at 0, in this case, times 0, or x is 0. And we go, how many intervals do we have to complete one cycle? We go to the high, mid, low, mid. So there are 4 intervals, and they're all the same. So that's why we're going to take the period and divide it by 4. Now if we take a look at these numbers, this is pi over 4, 2 pi over 4, which reduces to pi over 2, 3 pi over 4, 4 pi over 4. And then you can just sketch a little bit more here. The main thing I want to see is if you can label that complete period, you're doing okay. And that's it.